In this lecture, we're going to be looking at the types of connective tissue proper that we find in the body. So, what does connective tissue proper mean? You're probably thinking to yourself. So let's just dive right in and find out. So, connective tissue, as we've said before, is composed of living cells that's surrounded by a non-living extracellular matrix. And what makes different connective tissues different from each other is the type of cells that we find in them, the kinds of protein fibers that are found in that extracellular matrix, and then the proportions of each fiber type. So we can roughly classify connective tissues into two separate groups, the connective tissue proper and the specialized connective tissues. Connective tissue proper is called proper because it actually has that connective function. They are connective tissues that hold or bind two different parts together. The specialized connective tissues, we separate them out because they have functions that don't really relate to so much to holding things together. And so within that idea of connective tissue proper, there are two different kinds of connective tissues. They're the loose connective tissues, which are composed primarily of ground substance and the specialized cells, and have a lot fewer of the protein fibers in them. And the dense connective tissues, which are primarily fibrous, with very little ground substance, and then the cells run around in between the fibers, tending to them and doing whatever other characteristics that connective tissue has. So in this lecture, we're looking at the connective tissue proper. So let's dive in. And we'll start with the loose connective tissues. Areolar tissue is one of the loose connective tissues. In areolar tissue, fibroblasts are the most common cell type. Again, fibroblasts, these are the cells that build the protein fibers that we find in the connective tissue. And the ground substance has a real gel-like consistency. The primary protein fiber types are collagenous and elastic fibers. And so this gives the areolar tissue a very strong, but also somewhat moderately stretchy kind of characteristic. And it functions to bind the skin to the underlying organs. It is the subcutaneous layer that we find that binds the dermis to the underlying muscles. And it fills the space within a muscle. So there are nooks and crannies within muscles, and this areolar tissue fills those spaces. And we find it near or underneath most epithelial layers is where we find areolar tissue. Adipose tissue is also a loose connective tissue. And in adipose tissue, the adipocytes are the most common cell type. Now, initially, adipose tissue cells resemble fibroblasts, and they're busy making fibers and stuff. But if they are presented with extra nutrients, or extra energy, I should say, then they will convert that energy into a fat droplet, or they'll store that energy as a fat droplet, and will convert into an adipocyte. Once a cell becomes an adipocyte, it doesn't ever go back to being a fibroblast. And so losing and gaining weight after cells have become adipocytes is just about increasing and decreasing and increasing. Losing, of course, is decreasing the fat droplet size. Gaining weight would be increasing that fat droplet size. But the cells always remain. So once they're made, they're always there, and dadgummit, they keep calling for another pan of brownies and some of that ice cream that's in the freezer, and while you're at it, could you eat some peanuts and cashews? You get the point. So areolar tissue can convert into adipose tissue if that excess energy is available. And so we've got sort of an endless supply of these fibroblasts that are eager to take on the role of being an adipocyte. So what is the value of adipose tissue in the body? Well, two things. It stores energy, and we've talked, well, I guess we haven't talked really much in this class about it, but fat is an especially efficient energy storage molecule. We can store twice the calories in a gram of fat than we can in a gram of carbohydrate. And so it's a great energy storage means because it's relative to carbohydrates. It's much more lightweight to store energy as fat. And it can also insulate the body against temperature change and organs within the body against being shocked or being pushed around, being bumped. So when we fall, for instance, the kidneys don't rattle around in their spot there in the lower back. Instead, they are padded in that place by a lot of adipose tissue that helps to keep them from being jostled too much. A third kind of loose connective tissue is the reticular connective tissue. And as the name suggests, there's a the primary protein fiber in reticular connective tissue are the reticular fibers. And so we see this network of reticular fibers, and then the fibroblasts, and these are the nuclei of the fibroblasts, are out hanging around and secreting and tending to and repairing all of the reticular fibers. And this forms the framework then of a number of different organs in the body. The lymph nodes, the spleen, the liver, even bone marrow is all it is built around a framework of reticular fibers. Okay, so those are the loose connective tissues. Now let's take a look at the dense connective tissues. And remember, what makes a dense connective tissue is the increased amount of protein fibers that we find in that tissue. So dense regular connective tissue, and the opposite, or it's in contrast to dense irregular connective tissue. We'll get there in a minute. But dense regular connective tissue consists of very closely packed collagenous fibers, but they're arranged parallel to each other. So notice here in this dense regular connective tissue, we see these kind of wavy lines. Those are the fibers, the collagenous fibers that are arranged there. And they're kind of bound together by a network of elastic fibers. And relatively speaking, there are relatively few fibroblasts sandwiched in between these layers or the rows of the collagenous fibers. And they tend the fibers from that position there in the in that dense regular connective tissue. The primary locations of dense regular connective tissue in the body are the tendons and the ligaments. And because of this closely packed, and that's the regular part, they're arranged very parallel to each other. So that's what makes them regular. We'll see that irregular connective tissue, dense irregular connective tissue, has the protein fibers in that higgledy-piggledy way that we saw in areolar tissue too. So it's found in tendons and ligaments. Ligaments and lindens. It's found in tendons and ligaments, and it's very strong. When we pull, so here's a tendon with its rows and rows of collagenous fibers. As long as we pull away, along down the axis of the tendon or the ligament, they are very strong. But they have a tendency to break if we pull in this direction, or if we make a spiral twist on a tendon or ligament, it will break relatively easily. And so those lateral stresses need to be avoided. And this is why we get ACL tears or calcaneal, Achilles tendon tears in sports where there's a lot of planting the foot down and then twisting hard, like basketball or racquetball, tennis. They all have a tendency to damage ligaments because they pull ligaments and tendons in ways that that are weak, where the tendon, in directions where the tendon is weak. They tend to be very poorly vascularized as well, so once damaged, it takes a long time to get them to mend. And, and even once they've mended, they still can be weak as, for quite a while as the body is repairing and recuperating. So those are that's dense regular connective tissue. There's also dense irregular connective tissue. And in irregular connective tissues, there are still closely packed collagenous fibers, but they are not laid parallel to each other, but instead they cross over each other in random ways. And as we mentioned before, this interweaving allows them to withstand stress no matter which directions we pull, because no matter what, like if we're pulling it along this axis here, well, we've got this fiber and that fiber and that fiber and this fiber here that are all good at withstanding that pull. If we pull along this axis, we also have fibers that are roughly laid along that axis that are going to withstand the stretch. And the same if we were to pull along this axis. Again, more fibers that are laid roughly along that direction that give us strength, no matter which way we pull it. And the fibroblasts, again, are found, in and among all these fibers, tending to them and repairing them. And so we find dense irregular connective tissue in the dermis, deep to the epidermis, in the joint capsules. This is connective tissue that surrounds a joint and the fluid, and contains the fluid that lubricates the joint. And in the fibrous coverings that are found over the bones, over muscles, that cover the kidney and all the lymph nodes. So we see these very strong they're strong, not as strong as a tendon or ligament is when you pull along the axis of the tendon or ligament, because in a tendon, all of the fibers are arranged in that direction. So they don't have that amount of strength, but they have strength no matter which direction you pull them, is their special property, I suppose. Okay, so those are the two of the dense connective tissues. We've got a third. Elastic connective tissue is also a dense connective tissue because, again, the elastic fibers tend to be arranged in parallel strands. And these are found in organs, or this connective tissue is found in organs that need to be both strong and elastic. So the aorta, which withstands the highest of the blood pressure changes. The trachea, which has to be strong but elastic enough to be able to be shrunken, to be pulled in when the body requires there to be less airflow, and then relaxed when the body requires there to be greater airflow through the lungs. And even in between the vertebra, we have these pads of elastic connective tissue that help to absorb the shock of walking and running and jumping that we do to ourselves. So elastic connective tissue is a dense connective tissue, and it's characterized by these very dark, these staining, so they stain very dark, wiggly elastic fibers. All right, so there we are. All of the connective tissue proper described here, and in the next lecture we're going to look into some of all of the specialized connective tissues. You know what to do if you have any questions.